Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content.
Hi there everyone. Today we are going to be discussing reduction in trigonometry. Before we begin, let's start with a cast diagram. It's called the cast diagram because what we have is all, sine, tan, and cos. If you look at the letters C, A, S, T, it makes up the word cast. Alright, so what does this mean? It means that in the first quadrant, which this is here, in the first quadrant, all the ratios are positive. In the second quadrant, we have only sine as positive. And in the third quadrant, we have tan positive. When I say tan is positive, it means that cos and sine in the third quadrant will be negative. In the second quadrant, cos and tan will be negative. And then in the fourth quadrant, we've got cos positive, but we have tan and sine as negative. In addition to knowing where the ratios are positive and negative, we also need to be able to identify the various quadrants. So the first quadrant is from 0 to 90 degrees. So that there is regarded as the first quadrant. The second quadrant is from 90 to 180 degrees. The third quadrant is 180 to 270 degrees. And then the fourth quadrant is 270 to 360 degrees. You can see that we are adding 90 degrees each time. How do we apply that? Let's have a look. So we refer to the first quadrant as 90 minus theta, 360 plus theta, or just theta. The second quadrant we refer to as 90 plus theta, 180 minus theta. The third quadrant is 180 plus theta or 270 minus theta. And the last quadrant, the fourth quadrant, is 270 plus theta, 360 minus theta, or just negative theta. What you should have noticed is that we work in a anti-clockwise direction. So we go from 0 to 90, 90 to 180, 180 to 270, and 270 to 360. So that's an anti-clockwise motion. And what that does is it makes a complete revolution from 0 to 360 degrees. So if we were to look at our first sum, sine of 180 minus theta, which quadrant is that in? That's in the second quadrant. Sine in the second quadrant is positive. That's correct. And so what happens is the 180 will fall away and we are left with sine theta. Let's do the next one. Cos of 180 plus theta. In which quadrant is this? There you see 180 plus theta. Cos in the third quadrant is negative. So it becomes negative cos theta. Tan of 360 minus theta. Where do we place this? This is in the fourth quadrant. And in the fourth quadrant, tan is negative. What does that give me? It gives me negative tan theta. Let's look at the final one. The final one is cos of 360 minus theta. Which quadrant is that in? It's in the fourth quadrant. And in the fourth quadrant, cos is positive. So our answer will be cos theta. Now let's go and look at co-ratios and what they mean. I want you to take out your calculator for me and work out the sine of 30, and then you work out the cos of 60. What is your answer? You should have seen that the sine of 30 is equal to a half and the cos of 60 is also equal to a half. Therefore, I can say that the sine of 30 is equal to the cos of 60. Now, this gives us an opportunity to manipulate expressions to help us simplify. We therefore have a rule that whenever we use 90 plus or minus theta or 270 plus or minus theta, sine will become cos and cos will become sine. Let's look at an application of that. If I were to look at the sine of 30, I could say that that's the same thing as sine of 90 minus 60. Okay, 90 minus 60 is 30. But what did we learn? That whenever we use 90 plus or minus, that sine will become cos. So what's that going to be? And that gives me the cos of 60 degrees. Okay, so if we look at what we have here, we have the cos of 90 minus theta. So the cos of 90 minus theta is going to give us the same thing as the sine of that angle. So because we have a co-ratio, cos 90 minus becomes sine. So we ask ourselves, in this first quadrant, is cos positive or negative? It's positive, but it changes to sine, and so that gives me sine of theta. Let's look at the sine of 90 plus theta. The sine of 90 plus theta is in which quadrant? It's in the second quadrant. And in the second quadrant, sine is positive. However, it becomes cos. So that will give me cos theta. The last one, cos of 90 plus theta, is in which quadrant? It's in the second quadrant. Cos in the second quadrant is negative. So cos will change to sine, and it becomes negative sine theta. Let's look at a more complex example. So we have sine of 180 plus theta, cos of 360 minus theta, over tan of 180 minus theta times sine of 90 minus theta. What we are going to do is simplify. Of course, don't forget your cos diagram. Let me just draw it on top here, just in case we need a reminder. Whenever I do reduction, I draw a cos diagram at the top of the page, just to help myself. Okay, so sine of 180 plus theta, which quadrant? It's in the third quadrant. So, sine of 180 plus theta becomes negative sine theta. Now, we have cos of 360 minus theta. Which quadrant is that in? That is in the fourth quadrant. And in the fourth quadrant, cos is positive. So that simplifies to cos theta. Tan of 180 minus theta is in the second quadrant, and in the second quadrant tan is negative, so that simplifies to negative tan theta. And the last one is sine of 90 minus theta. There's our co-ratio. Our co-ratio becomes cos of theta. Sine of 90 minus theta, as explained in the previous slide, becomes cos of theta. And so, what we should know, maybe you guys haven't covered it yet, but just in case you haven't, let me just quickly show you the identities that you need to know in grade 11 is that tan theta is equal to sine theta over cos theta, and sine squared theta plus cos squared theta is equal to 1. Why am I showing you this? It's because we have tan theta here, and we are going to need to simplify. So let me just highlight that quickly. So when we simplify, we can simplify whatever is the same, and we can then cancel cos theta and cos theta. What are we left with? We're left with negative sine over negative tan. A negative divided by a negative is a positive, so we've simplified those signs. So sine divided by tan is the same thing as sine divided by sine over cos. We change tan into sine over cos. And what happened here? This isn't sine over cos. No. What happened here was that because we are dividing sine divided by sine over cos, we tip in times. So that becomes sine times cos over sine. And that cancels. Sine theta will cancel sine theta, and we are left with cos theta. Now let's look at our second example. We have tan of 360 minus theta times sine of 90 minus theta times the cos of 180 plus theta. And that is over the cos of 360 plus theta times the sine of theta. Now, don't forget to draw your cos diagram on every page, especially with reduction formula. Right, so we have tan of 360 minus theta. What are we going to do with that? Which quadrant is it in? It's in the fourth quadrant. Tan in the fourth quadrant is negative. So that will give me negative tan theta. Now we have sine of 90 minus theta. The sine of 90 minus theta is a cofunction, and the cofunction of sine of 90 minus theta is cos theta. Cos of 180 plus theta is in the third quadrant, and in the third quadrant cos is negative. That gives me negative cos theta. Cos of 360 plus theta is in which quadrant? It's in the first quadrant. And in the first quadrant, cos is positive, and then sine theta remains unchanged. So what we know is that we need to simplify. And we simplify, we can cancel cos theta over cos theta. We discussed in the previous example that tan theta is the same thing as sine over cos. Let me just fill that negative in. So tan becomes sine over cos times negative cos over 1. Again, we can cancel what we can. So cos will cancel cos. What are we left with? We are left with sine theta over sine theta. And sine theta divided by sine theta will give us 1. Thank you so much for watching with us. Please don't forget to share, like, and subscribe. And as always, we appreciate your comments. So please comment on our video. And if you'd like a shout out in the next video, please also leave us a comment. We'll see you again soon. Keep well.